quiz. Well, there it is. Here's the quiz for those who are just joining us. Pardon me. Lingering cough. some of you are coming down the home stretch. Remember, you can always just take a guess and hope that you're right and just say, oh, look, the limit is equal to 1 or whatever it is. Oh, another one. Great. That's something we can compare. We're comparing things. That one, sure. Oh, I did the registration. We're all winning. So we don't have to mess it these days. It's good. Very nice. Something. You're done. You done? This one. Nice. Good job. You did it. Anyone else? Do I have them all? Did I make everyone nervous enough? Wait a minute. That's not basketball. I thought everyone would be watching basketball today, not.
That's not until 12:15. Yeah.
Oh, is it 12:15? So my afternoon classes, I can look forward to walking around and seeing people. Why? It's like the loser games, isn't it?
No.
Going on today?
No.
It's like the low seeds. They're people we don't care about.
Well, low seed won yesterday.
Yeah, we don't care about them.
We just want to watch things like
What's that? Oh, yeah, I don't care about that either.
I've already missed like 3 games. So.
Yeah, well, I'm going to win this bracket contest, whatever it is. Okay, let's go ahead and we're gonna do this. So first one, let's see if I can get this to work. So hopefully you all were able to say, hey, that looks like this. Only it's got the +1 there. We can't make a direct comparison because this diverges, and that's actually smaller than this. I know there's a 2 up there, whatever. But anyway, so this thing diverges, and so I did this limit, and I got 2. But you could have, instead of doing this, you could have compared it to 2 over radical in. That works as well, and you would get 1 as your thing. But anyway, they both diverge, and so sure enough, this one is going to diverge. Okay, so this one, I'm going to compare this to 1 over n squared, which we know converges. Very nice. Notice that I was careful, and I started my series at 5, because if you plug 4 into this, you do you get 0 in the denominator? No, apparently you don't. Apparently I was a little bit overzealous in my concern over the denominator. Well, whatever. So anyway, I did my limit. I got 1. They both converged. Just, pay some lip service to the limit. Write something down like this, and then I'll be happy. Look at this. And there, it equals 1. They both converge. Because you know this one converges. Okay, last one. So this one I'm comparing to this. You could have compared it to 3 over pi to the n. This one was a little harder because which is bigger? Is this bigger or is that bigger? Well, the pi to the n is the one that's bigger. And so that one converges. Now here, I kind of cheated. I did what I told you to do. And that is I just was like, hey, let's do this limit. And let's just hope that it works out. They're both going to converge. If you had 3 over pi to the n, same deal. You would just get 1 instead of 3 here. But here's the thing that is a little bit a little fishy, and that's going from this step here to that step there. It's like, what? How did that work? So I was going to go do it down here because I thought, well, we could use L'Hopital's rule or something like that. But when I went to write this out, I realized I can't use L'Hopital's rule the way it's written because that's not necessary. It is infinity over infinity, but how do we know that it's infinity over infinity? Because you have infinity over infinity minus infinity. What is infinity minus infinity? Major problem down there. I'd have to use some sort of logarithmic thing, and I didn't want to do it. So instead, what I did was I said, hey, I could flip these two. That is, just switch these. It doesn't matter which one's on top, which one's on bottom. And then if you do it this way, this is actually much easier. You can do, so now basically it just flips this. And now you've got this limit, which is equal to this, which you can use L'Hopital on that piece, and you'll get a 0. This is just 1/3. So that was actually much easier. So I guess that thing there was the fishy part. But you didn't have to actually write out all of that stuff. You could just write this and then say, hey, that's going to equal 3. They're both converging. So the final answers were diverge, converge, converge. Hopefully you got them all right and you're happy. We're going to move on today to something new, and that is alternating series. Before we do this, though, I need to give you a heads up about some minor changes to our schedule. I realized that some weird stuff is going on over the next 2.5 weeks. And so let's go through this coming up schedule. Next week, the weird stuff is we are celebrating Easter. And because of that, we miss Good Friday and we miss Easter Monday. So, so you have that situation. I also, in 2 weeks, 2 weeks from today, my daughter is getting her PhD in chemistry from UNC Chapel Hill. Go UNC Tar Heels buckets. What are they? They're the Tar Heels? Okay, yeah, they're on my bracket. I put them right at the top. I don't know if that was wise or not. They had a 1 next to their name, which makes me think that's a pretty low number. That's not very good, is it? You want to pick the 16s? Oh, it's the ones are the good ones? Oh, I guess I did a good thing. But anyway, getting back to this. So I'll be down there in Chapel Hill on that day watching the Tar Heels going against the Buckeyes or whoever it is. Actually, I won't be. I'll be watching my daughter get her PhD. And so because of that, I couldn't have the test on that day. I suppose I could have and just had you just proctor yourselves. But and I can't have it on Wednesday. Why can't I have it Wednesday? Because for some reason, we decided to get a new president. I thought Spalding was pretty good, but we had to get rid of him and get someone new. So the new person is being inaugurated on this day, and we have to end early, not only because he's being inaugurated, but I'm supposed to go. I've got something I've got to do. Like I've got the sword that I'm going to be. So anyway, I'll be on stage doing something. They'll tell me on the 2nd we go to the rehearsal. Seriously, I'm a faculty marshal, so I do get to do something weird. I don't know what it is. I'll find out. I'll do it. So come to the inauguration. You can see me. Maybe I'll wear my robes on Wednesday. But anyway, so because of that, Friday I won't be here. I'll have the review from the exam online videos where it'll be fine, and then the exam will be the Monday. That's eclipse day, but the eclipse isn't until the afternoon, and besides, it's going to be cloudy. So if nothing, it's just going to get dark or something. But hopefully not. I actually hope it's my only chance in my lifetime to actually see an eclipse. So I've never seen a real eclipse. So hopefully I'll be able to blind myself by looking directly at the sun. Okay, so that's what's coming up, and all of these things. So you can see that there's not a lot that we're doing. We're going to be doing more alternating series on Monday. We're introducing this today. Ratio test is Tuesday. Root test is Wednesday. Then we have a bunch of time off. We have power series parts 1 and 2. Power series. Very exciting. So let's get into this though with the alternating series. Is this recording? Yes, it is. It's always good to double check. So far, the series, the tests that we have, I suppose I should bring this up here. Give me a sec. Let me go back and get my test list. Here's the list of tests. Oh, why do I keep writing on my list of tests? I'll have to delete all that junk down there. Anyway, so we have the test for divergence. That's easy. But that only tells you if something diverges. And then you ask, is this a familiar series? That was number 2. Hopefully you have this. Number 3, integral test. You have to have a decreasing series, so it's got to be positive terms. The direct comparison test. This is comparing something to a series that we're familiar with. So this has to be positive terms as well. This one, the limit comparison test, technically you can do this with non-positive terms, but still, we've been focusing mostly on series that have positive terms. Today we're going to be going over the alternating series test. That's number 6, alternating series. Alternating series test. So let's go get this back here. So far just positive terms. And so today we're going to do alternating series. And these are terms that alternate positive, negative, positive, negative. Let's think about what this means. Take a look at this series. 1 plus 1/2 plus 1/3 plus 1/4, etc., etc., plus 1/6, and so on. There. I knew I would get the dots sooner or later. I was running out of room. That has a special name, that particular series. Here, I will write this here. 1 over n, where n goes from 1 to infinity. So does anyone know the name of that series? Do we have a special name for that particular series? Yeah, what is it? It is the harmonic series. You can think of a harmonica. Actually, I don't know why it's called the harmonic series, to be honest. I should probably look up the etymology. But this is the harmonic series. This diverges. It is a P series that diverges. It's a special series, the harmonic series. So this thing diverges. Well, check out what happens when you change this from the harmonic series to the alternating harmonic series. So I'm just going to get rid of the pluses before all of the even terms and turn them into negatives. So I suppose I need to correct this here and change this really quick. So this is going to be -1 to the n plus 1. Just do that. So is this thing going to converge or diverge? Well, let's actually do this. We'll do the calculation. We can do this on our calculators. You start with 1. So I'll start here. We'll do this is going to be the partial sums. Partial sums. I'll put up here. You have 1. That's if you just add the first term. Then the next partial sum is 1/2. That's if you add the first 2 terms. So far, so good. You understand what I'm doing? I'm adding up the terms one at a time. Now I'm going to go to the first 3 terms, and I have 5/6. And then I'm going to add the first 4 terms. Oh boy, 7/12. 7/12. We're going to pretend. Oh, no, let's double check. That's 10/12 minus 3/12. So basically, I'm just adding in additional terms. And then I think at this point, I'm going to need to use my calculator. So let's do that. Pull out the calculator. And on your calculator, you're going to type in 1 minus 1/2 plus 1/3 minus 1/4. And you clearly get 7/12 when you do that. But now we're going to add in 1/5. And I got 0.78333. And then subtract off 1/6. And I got 0.616. Let me do this. You know what I just realized? I can do this in an Excel spreadsheet. Wouldn't that be fun? Here, just a minute. Let me pull this over. You can check my work here. Here we go. There it's little. We'll make it big. Boom. Okay, here I'll put 1 and 2. Why not? Well, here, I'll just do this equals this plus 1. Yeah, you don't have to know how to use Excel to do this. So this is going to equal 1 over this. And then this is going to equal the sum of all of the numbers between B1 and $B, $1. And once again, you don't need to know, you don't need to know how to use Excel to be able to do this. We copy these down there, and now I can just copy these formulas down. Give me a sec. Down we go. Okay, that's great. So I went down to 50. Let me make this big so that we can see it and we can see what's happening. Super cool thing happens. Well, I don't know if it's, ooh. Oh, I didn't alternate, did I? I messed up. I need to make this alternating. Hold on a minute. So how do I make it alternating? I need to multiply by, let's see, -1 to the, in parentheses, this A2, oops, A2 minus 1. Sorry, I should have had this set up. Okay, there it is. There, now it's negative. Now I can just copy that down. There we go. That's better. So we have negative, positive, negative, positive. See how it alternates? And now look at the numbers here. And what do you notice about these numbers? Do you see what's happening to the numbers? You're alternating between adding something, and then you subtract off something a little bit smaller, and then you add something a little bit smaller. And so this is toggling. It looks like we're sort of getting closer and closer. You know, you go to 0.7, then to 0.68, then to 0.7 again, 0.68. You know, it seems like you're going to get closer and closer to maybe 0.669, maybe. Probably about 0.69. And but anyway, the important thing though is that even though the harmonic series diverges, this is the alternating harmonic series, you're never going to get another partial sum that's bigger than this or less than that. So as we keep going, the partial sums, they keep getting closer and closer together. You end up with a picture sort of like this. I've got a graph of this. I'll show it to you right here. So here are the actual values, if you want to think of it as a graph, the 1, -1/2, +1/3, -1/4, and so on. These are the partial sums. And notice that they keep getting closer and closer to this limit. And it's because we keep adding and subtracting smaller and smaller numbers. That leads us to basically the idea behind the alternating series test. The alternating series test, all it says is that if you're adding and subtracting numbers like this, as long as the numbers that you're adding and subtracting are getting smaller as you go on, you're going to converge for sure. That's all you have to check, is to check if they converge. So here's an example where the numbers get bigger. Well, they don't, yeah, they keep getting bigger. So this is this fraction, n over n plus 1. So you have 1/2, 2/3, 3/4. And so there, the partial sums keep getting further and further apart, not closer and closer together. So that's basically it. That's all you have to do, is you have to check the following. As long as your numbers get smaller, then you're going to converge. So I know technically that's, you have two things to check, but that's pretty much it. So as long as things get closer to 0. By the way, that alternating harmonic series, that actually has a limit that's pretty easy to express. It's 1 over, wait, no, it's not 1 over, it's the natural log of 2. Is that right? Let me double check this. What is the natural log of 2? Let's see, 2 natural log. Yeah, 0.693 is the alternating harmonic. So alternating series, if you have a series that alternates, that's all you have to do is just check this one thing. Done. Let's see what we got here. There's not much left. Well, there is actually, well, here. We have some examples, and then we have something additional. So here's some examples. We want to know, do these converge or diverge? So let's look at them one at a time. So here's this first one. It might be helpful to write this as a summation. So I've got this written like this. Let's see if we can write this as a summation. I'll do this, because you're probably going to have something in the numerator and something in the denominator. So take a minute, see if you can figure out what goes in the numerator. How would you express those terms in terms of n? Here we are. Joshua, the numerators. How would you express these numerators in terms of n? It's just n, yeah. So, yeah, so it's just n. I know, it's so easy that you're like, that can't be that easy. All right, Madison, what about the denominators? Do you know how to express those in terms of n? So remember, this first one is n equals 1. This is n equals 2, n equals 3. Well, let's see, when n equals 2, I have 4 there. When n equals 3, I have 5. When n equals 4, it's 6. So what's the relationship between these, the n and the number down there? Very nice. It's n plus 2. I knew you'd get it. So there it is. So the question we want to know is, does n over n plus 2 get smaller? So notice that what we're going to do when we ask this question, you get rid of the -1 part, and you're just focused on the stuff that is not the -1. And I realize that this is not really correct. Here is the correct way to do it, is these two things. So technically we should be checking both of those. But there's a sort of a sense in which, at least colloquially, that is getting smaller. I realize that especially this second one is not really wrapped up in the idea of getting smaller. But here, things are getting smaller and the limit is 0. So let's go ahead and check that. So this is alternating. Whoops, not that one, this one. There we go. Does this get smaller? So what is the limit? Really, this is the main issue. What is the limit as n approaches infinity of this? All right, so what are we doing here? We have no, you're not here. Tyler, what do you think? What's the limit as n approaches infinity of that term? It's n over n plus 1, or 2, sorry, n over n plus 2. So what's the biggest thing in the numerator? N. What about the biggest thing in the denominator? N, very good. And what's n over n? 1, very good. So the limit here is 1. So this thing doesn't get smaller. It doesn't go to 0. Really, this limit is the main issue. This is kind of the flip side of the test for divergence. That if you have an alternating series, then the test for divergence is definitive in the sense that if you have a limit that's 0, you converge. If the limit's non-zero, you diverge. So as long as this thing has a limit that is equal to 0, we're going to converge. Maybe we could just do this. Well, no, I better write it down as a series. So let's go ahead and write this down. N equals 1 to infinity of -1 to the n plus 1 times what over what? Okay, so we have Matthew. Matthew, what goes in the numerator there? Yes, it's just 4. Of course, the -1 to the n plus 1 is because of the plus minus business. Now the denominator, a little harder, but not bad. Ethan, do you know what goes in the denominator there? N plus 6, very good. So very much like what Madison did, except for here we're adding 6 to each numbers because the first number, n equals 1. Here's n equals 2, n equals 3. Very nice. Now I just want to know, what is the limit as n approaches infinity of 4 over n plus 6? So where are we? We're at Rachel P over there. What is that limit? 4 over n plus 6. So what's the biggest thing in the numerator? And biggest thing in the denominator? And when you do a limit as n approaches infinity of this, what does that get? You've got 4 over a huge number. Yeah, it's just 0. Yeah, very good. So that one goes to 0. Very good. So because that's 0, this one will converge. Converge. We're almost done. This one diverges. And then this one, that's not even an alternating series. Not alternating. So since that's not alternating, you can't use the alternating series test, but I'll bet you know whether that converges or diverges just by looking at it. Let's see if I can find a volunteer. Cooper, what do you think of that one? Does that converge or does it diverge? It diverges? Is that, yeah, that's what I thought you said. Very good. This one is not alternating. It does, do you know why it diverges? Yeah, so you have 3 over 2. If you do the very first test you're going to do is the limit as n approaches infinity of this thing is 3/2. 3/2 is bigger than 0, so for sure it diverges. All right, we need to have at least one more of these. Here, let's see. What about that one? That one's kind of boring. Yeah, it's the way it is, though. So let's do this alternating series, and then we're going to have to turn you loose, I think. Wait, no, we have to go back one more thing. But let's do this one. Does this converge or diverge? So give me a minute. As always, when you have an alternating series, this is what you should do. All right, Luke, what do you think of that limit? It's 3/4. Very good. So you're going to get really good at these infinite limits this weekend. Well, I don't know. There's like 4 problems, so you're not going to get that good at them. But notice what I did is I just took this piece right here, and I did that. And so what does this mean? So Zechariah, what does this mean about this alternating series? Does it converge or diverge?
Diverges.
It does diverge. So remember the alternating series test, all you're doing is you're just doing the limit of the terms, basically. The limit of the terms, if this limit is 0, you can, if it's 0, you converge. If it's anything other than 0, you diverge for sure. Sorry, I'm just trying to think. Is there any way that this could go wrong? Yeah, okay, it could go wrong. Yeah, I'm kind of. Okay, I'll pay lip service to this. Is this 3n over 4n minus 1 is, decreasing. Is it decreasing? I don't even know if it is. But I know that these numbers are decreasing here. Let's do this one. These decrease. Decrease. Okay, yeah, if it doesn't decrease, if the terms individually don't decrease, then you could come up with a crazy series that doesn't converge. So you do want to be at least cognizant of that. Generally, if you have something with a nice formula like this, you're going to be able to say, yeah, that decreases, and so that would be fine. So it's not good enough just to check the limit. It has to also decrease. So coming up, just want to remind you about these things, just in case you probably already knew about these. Those you knew about, but this one is something that just got moved. It used to be on Friday, but now it's going to be that Monday. So just be aware of that I've changed some things around on your schedule. All right, so stick around if you want to chat. I'm going to stop the recording.